Welcome to Calming Cosmos. I'm so glad you're here with us tonight. Before we begin, I'm curious, where are you right now? A quiet bedroom with the lights low, perhaps a comfortable couch where you've finally settled for the evening. Or maybe you're looking up at your own night sky, wondering about the stars above. Wherever you are in this world, you're exactly where you need to be. Find yourself a comfortable position. Let your body sink into the softness beneath you. There's nowhere else you need to be. Nothing else you need to do right now. If you enjoy these peaceful explorations through space, a like and subscription really do help this sleepy little channel keep going. And if you're already subscribed, thank you. Truly, your support means more than you might realize. Tonight, we're going on a journey together, a gentle drift through our cosmic home, the Milky Way galaxy. We'll explore the spiral arms that stretch across hundreds of thousands of light years. Discover the ancient core where billions of stars orbit in peaceful harmony, and find our own small place in this vast galactic family. There's no pressure to stay awake for this entire journey. In fact, if you drift off along the way, that's perfectly wonderful. That's exactly what this is for. Let the words wash over you like gentle waves. There's no test at the end. No need to remember anything. Just let yourself float peacefully through the galaxy we call home. Take a slow, deep breath. Feel your chest rise and fall. Rise and fall. Let any tension in your shoulders release. Let it melt away, like stardust drifting through space. Tonight we travel through 200 billion stars, through clouds of gas and dust where new stars are born, through spiral arms rotating slowly over millions of years. And we find something remarkable along the way. We find that we belong here, that this galaxy, this spinning island of stars, is our home. So take one more deep breath and let's begin our gentle journey through the Milky Way on a clear, dark night. Far from city lights, you can see it, a faint, glowing band stretching across the sky like spilled milk or a river of light flowing through the darkness. The ancient Greeks saw it and called it Galaxias Kyklos, the Milky Circle. The Romans called it Via Lactea, the Milky Way, and the name stayed with us across centuries. Different cultures saw different things in that pale glow. The Chinese called it the Silver River, separating two lovers in their mythology. Aboriginal Australians saw it as a river in the sky, connecting the earthly world to the celestial realm. Nordic peoples thought it was the path souls took to reach Valhalla. But what you're seeing when you look up at that pale glow is something far more magnificent than our ancestors ever imagined. You're looking at your home. From the inside, the Milky Way is a galaxy, a vast, rotating island of stars, gas, dust, and invisible dark matter, all held together by gravity. It's shaped like a disk, a flat spinning spiral, with arms that curve outward from a bright central bulge. Imagine a fried egg, with the yolk representing the core, and the white representing the disk spreading outward. But add spiral patterns, graceful curves, sweeping through that disk. If you could float above it, billions of light years away, and look down, you'd see something breathtaking, a perfect spiral, glowing softly against the black void of space, like a cosmic pinwheel, frozen in time, yet eternally spinning. The Milky Way contains roughly 200 billion stars. 200 billion. That number is almost impossible to comprehend. If you counted one star per second, without stopping, it would take you over 6,000 years to count them all. Each one, a sun, many with their own planets, their own worlds, their own stories unfolding across time. Some of those stars are ancient, nearly as old as the universe itself. Born when the galaxy was young and chaotic. Others are newborns, just igniting their nuclear fires, in clouds of gas between the spiral arms. Some stars are massive, burning blue-white, living fast and dying young in spectacular explosions. Others are small, red, cool, burning their fuel so slowly they'll outlive the universe as we know it. And somewhere, in one of those outer spiral arms, orbits a modest yellow star. Not the brightest, not the largest, just average, steady, reliable. That star is our sun, and circling that sun is a small blue planet, Earth, home. The Milky Way is enormous. If you tried to cross it, traveling at the speed of light, the fastest speed possible in our universe, it would take you 100,000 years to go from one edge to the other. Light itself, the fastest thing in the universe, traveling at 186,000 miles per second, would spend 100,000 years crossing our galaxy. To put that in perspective, light from the sun takes just 8 minutes to reach Earth. Light from the nearest star system, Alpha Centauri, takes about 4 years. But light from the far edge of our galaxy takes 100,000 years. And yet, the Milky Way is just one galaxy among hundreds of billions scattered through the observable universe. One island in an infinite cosmic ocean. Some galaxies are larger, containing trillions of stars. Others are smaller, dwarf galaxies with just a few million stars. Some are spirals like ours. Others are elliptical, irregular, peculiar. But it's our island, our home. The galaxy is rotating, spinning slowly, like a cosmic carousel, like a hurricane in space. but taking hundreds of millions of years to complete one turn. Our Sun and all the stars near us orbit the galactic center at roughly 515,000 miles per hour, fast enough to circle the Earth in just over 3 minutes, fast enough to travel from New York to Los Angeles in about 3 seconds. And yet, because the galaxy is so vast, because the distances are so immense, it takes our Sun about 225 million years to complete one full orbit, one galactic year. The last time our Sun was in this exact position in the galaxy, dinosaurs walked the Earth, huge reptiles ruling the land beneath the same galactic sky. Tyrannosaurus rex, Triceratops, Brachiosaurus, all living their lives while the Sun slowly orbited the galaxy. In another 225 million years, when our Sun returns here again, Earth might be unrecognizable. The continents will have shifted, new mountain ranges will have risen, old ones will have eroded away, new species will have evolved. Perhaps intelligent life will still exist, perhaps not, but the Milky Way will still be here, spinning, patient, eternal. The galaxy has structure, layers, regions, each one unique, each one playing a role in the grand cosmic architecture. At the center lies the galactic core, a dense, bright bulge packed with ancient stars, billions of them orbiting tightly around something mysterious and powerful at the very center. The core glows with the combined light of all those ancient suns, creating a beacon visible across intergalactic space. Surrounding the core, the galactic disk spreads outward. This is where we live, in the flat, spiral region, where stars are organized into sweeping arms. The disk is thin, only about 1,000 light-years thick in most places, but stretches 100,000 light-years across, like a cosmic pancake, rotating slowly, forever. And beyond the disk, stretching far into space, is the galactic halo, a spherical region, sparse, quiet, where ancient globular clusters drift like cosmic lighthouses. The halo extends perhaps 200,000 light-years from the center, wrapping the entire galaxy in a gentle, invisible embrace. The Milky Way is not alone. It belongs to a small family of galaxies called the Local Group. About 80 galaxies in total, bound together by gravity, drifting through space as a cluster. Most of these galaxies are small, dwarf galaxies, containing just a few billion stars, orbiting around the two giants of the Local Group. Those two giants are the Milky Way and Andromeda. Our closest large neighbor is the Andromeda galaxy, another spiral slightly larger than ours, containing perhaps 1 trillion stars, about 2.5 million light-years away. On a dark, clear night, You can see Andromeda with the naked eye, a faint smudge. In the constellation Andromeda, that smudge is a galaxy, an entire galaxy, visible to your unaided eye. And something remarkable is happening. Andromeda is moving toward us, slowly, inevitably, at about 250,000 miles per hour, in about 4.5 billion years. The Milky Way and Andromeda will collide, not violently, not destructively, but gracefully. Two spiral galaxies merging over hundreds of millions of years to form something new. Stars will pass between each other like dancers, rarely colliding because the distances between stars are so vast. Gas clouds will crash together, triggering enormous bursts of star formation. The combined gravity will distort both galaxies, pulling them into new shapes, creating tidal streams of stars. Eventually, they'll form a giant elliptical galaxy, peaceful, majestic. Astronomers have already given it a name: Milkomeda, the merger of Milky Way and Andromeda. But that's far in the future. For now, the Milky Way spins quietly, its spiral arms rotating, its stars orbiting, its story continuing. And we are part of that story. Every atom in your body was forged inside a star. Carbon, oxygen, iron, calcium, nitrogen, phosphorus, all of it created in the nuclear furnaces of ancient suns that lived and died long before our own sun was born. Those stars exploded in supernova explosions, scattering their elements into space, enriching the clouds of gas and dust between the spiral arms. And from those enriched clouds, new stars formed. Second-generation stars, third generation, each generation inheriting the elements created by the previous one. Our sun is a third or fourth generation star, born from a cloud already enriched with heavy elements, and from the disk of material around the young sun, planets formed, rocky planets like Earth, made from the heavier elements, gas giants like Jupiter, made mostly from hydrogen and helium. And on one of those rocky planets, those heavy elements came together in increasingly complex ways. Molecules formed, organic molecules, amino acids, proteins, DNA, cells, life. We are, quite literally, made of the Milky Way, stardust, shaped by gravity, animated by chemistry, given consciousness through billions of years of evolution, looking back at the galaxy that made us. So when you see that faint band of light in the night sky, remember what it truly is. It's home, your home, a vast, spinning island of 200 billion stars, stretching across 100,000 light years, ancient, beautiful, patient, and you are part of it. every breath you take contains atoms that once floated through interstellar space. The water you drink was created in the hearts of stars. The iron in your blood was forged in a supernova explosion that lit up the galaxy billions of years ago. You are not separate from the cosmos. You are the cosmos, expressed in human form. Let's drift closer now and explore the spiral arms, where stars are born and worlds take shape. If you could hover above the Milky Way and watch it over millions of years, you'd see something mesmerizing. The spiral arms, rotating slowly, like pinwheels of light, sweeping through space, creating patterns that persist across cosmic time. Our galaxy has 4 major spiral arms, each one a vast river of stars, gas, and dust, stretching across tens of thousands of light years. The Perseus arm, the Scutum Centaurus arm, the Norma arm, the Sagittarius arm. Each arm glows with the light of billions of stars, particularly the bright young blue stars that form within them. From a distance, these arms trace out the galaxy's structure, making it visible across millions of light years of space. And between these major arms, smaller branches reach outward. Spurs, feathers, delicate structures that trace the galaxy's hidden patterns, like tributaries feeding into great rivers. Our Sun lives in one of these smaller structures, a minor arm called the Orion Spur, or sometimes the Orion Arm. It's a quiet neighborhood, not too crowded, not too empty, just right for a stable star system where life might emerge and evolve. And one day look up at the stars and wonder, the nearest major spiral arm to us, the Perseus arm, is about 6,500 light years away. The Sagittarius arm is about 10,000 light years in the other direction. We sit comfortably between them in a relatively calm region of space. The spiral arms are not solid. They're not like the arms of a pinwheel, rotating as rigid structures, all moving together. Instead, they're density waves, regions where stars and gas naturally bunch together, creating a pattern that persists even as individual stars move through it. Think of it like traffic on a highway. Cars slow down when they reach a jam, creating a wave of congestion. The jam itself doesn't move with the cars. It's a pattern that persists as cars flow through it. Some cars enter the jam from behind, slow down, then exit from the front and speed up again. The spiral arms work the same way. Stars move through them, slow down slightly as they pass through denser regions, then speed up again as they exit. The arms themselves rotate at a different speed than the stars, creating a persistent pattern in the galaxy's disk. This elegant mechanism was discovered in the 1960s by astronomers trying to understand how spiral patterns could persist for billions of years without density waves. The spiral arms would wind up tighter and tighter as the galaxy rotates, eventually disappearing. But density waves keep the pattern stable, beautiful, eternal, beautiful, elegant, self-organizing. The spiral arms are where star formation happens. In the space between stars, enormous clouds of gas and dust drift silently. Molecular clouds, some of them hundreds of light years across, containing enough material to build millions of stars. Millions. These clouds are cold, just a few degrees above absolute zero, about minus 260 degrees Celsius. Dark, dense, nearly opaque to visible light. Inside these clouds, molecules can survive. Hydrogen molecules, water molecules, carbon monoxide, methane, even more complex organic molecules, the building blocks of life, floating in the darkness between the stars. But when a molecular cloud enters a spiral arm, something changes. The increased density, the gravitational pressure, compresses the cloud. Parts of it begin to collapse, slowly at first, then faster as gravity pulls inward, overcoming the internal pressure trying to push outward. Within these collapsing regions, heat builds. As gas falls inward, gravitational potential energy converts to kinetic energy. To heat, pressure rises. The cloud fragments into smaller pieces, each one contracting independently, forming dense cores. These cores continue to collapse over thousands of years, over hundreds of thousands of years. They shrink, they heat, they spin faster as they contract, conserving angular momentum like a figure skater pulling in their arms. And then, in the densest cores, where pressure and temperature reach a critical point, where hydrogen atoms are squeezed so tightly they begin to fuse, nuclear fusion ignites. A star is born. The newborn star glows brightly, suddenly, blasting intense radiation into the surrounding cloud. The ultraviolet light ionizes the remaining gas, making it glow. The stellar wind, streams of charged particles, pushes back the remaining gas and dust, carving out a cavity, revealing the star within. More stars ignite nearby, dozens, hundreds, sometimes thousands in a single cloud. A stellar nursery, where an entire generation of stars awakens together, siblings born from the same cosmic womb. These young star clusters shine brilliantly, illuminating the spiral arms from within. Their blue-white light, the signature of hot, massive stars, traces the galaxy's structure, making the spiral pattern visible across vast distances. If you look at images of distant spiral galaxies, the bright blue arms you see are these regions of active star formation, stellar nurseries glowing with the light of newborn suns, marking where molecular clouds have recently collapsed. where the next generation of stars has just been born. But star formation is not gentle, not entirely peaceful. The most massive stars, those with 20, 30, 50 times the mass of our Sun, burn hot and fast. They're profligate with their fuel, fusing hydrogen at tremendous rates, shining with the light of millions of suns. They live only a few million years before exhausting their fuel. A cosmic blink, our Sun will live for 10 billion years. These massive stars, just a few million, and when they die spectacularly. A supernova explosion. The star's core, having fused all its fuel into iron, can no longer support itself against gravity. It collapses in less than a second, then rebounds, blasting the outer layers into space at 10,000 miles per second, 30,000 miles per second, a significant fraction of the speed of light. The explosion releases more energy in a few seconds than our Sun will release in its entire 10 billion year lifetime. For a brief moment, the supernova outshines the entire galaxy. The shockwave races outward through the spiral arm, expanding, glowing, creating a supernova remnant that persists for thousands of years. And as it expands, it compresses nearby molecular clouds, triggering new waves of star formation, death leading to birth, an endless cycle, repeating across the galaxy, across cosmic time. The elements forged in the dying star, carbon, oxygen, silicon, iron, scatter into space, enriching the interstellar medium, providing raw material for the next generation. The spiral arms are also home to something beautiful: nebulas, glowing clouds of gas, ionized by nearby stars, shining in brilliant colors, red from hydrogen atoms, transitioning between energy levels, green from oxygen ions, blue from helium and sulfur. The Orion Nebula, the Eagle Nebula, the Carina Nebula, the Lagoon Nebula, vast cathedrals of light and shadow, where stars are being born right now, this very moment. These nebulas are enormous. The Orion Nebula, one of the closest to us at about 1,250 light-years away, is about 24 light-years across. If you could place it where our Sun is, it would stretch halfway to the nearest star system, Alpha Centauri. And within that glowing cloud, astronomers have discovered thousands of stars forming, protostars, wrapped in cocoons of dust, slowly gathering mass, preparing to ignite. Young stars, just a few 100,000 years old, still surrounded by disks of material from which planets might form. The Hubble Space Telescope has photographed these regions in exquisite detail. Pillars of dense gas, eroded by stellar winds, but still giving birth to new stars at their tips. Protoplanetary disks, seen edge on, silhouetted against the glowing background. Bow shocks, where fast-moving young stars plow through the surrounding gas. These images are not just beautiful, they're windows into our own past. Our sun, formed in a nebula like this 4.6 billion years ago, surrounded by sibling stars, most of which have long since drifted away, scattered across the galaxy, their family connection lost to time. The spiral arms rotate slowly. Our sun completes one orbit around the galaxy every 225 million years, but the spiral arms themselves rotate at a different speed, slower than the stars in the inner galaxy, faster than the stars in the outer regions. This means our sun drifts in and out of spiral arms over tens of millions of years, like a boat crossing waves on an ocean. Right now, we're between the Perseus arm and the Sagittarius arm, residing in the Orion Spur, a relatively calm region. The density of stars here is about average, not too high, not too low, but tens of millions of years ago, our sun passed through the Perseus arm, and tens of millions of years from now, it will enter the Sagittarius arm. Does this matter? Possibly. Some scientists think that passing through spiral arms might affect Earth. The increased density of stars means more nearby star systems, more opportunities for close encounters, though still incredibly rare. The higher rate of supernovae means more cosmic radiation, high-energy particles streaming through space, potentially affecting Earth's atmosphere, its climate, its biosphere. Could this trigger ice ages, mass extinctions, changes in Earth's climate and evolution? It's uncertain. The effects, if they exist, are subtle, gentle, spread across millions of years. Not sudden catastrophes, but gradual influences, perhaps nudging the course of life's evolution in subtle ways. Some researchers have tried to correlate the sun's passage through spiral arms with ice ages and extinction events in Earth's geologic record. The data is intriguing, but not conclusive. The debate continues, but it's a reminder that we are not isolated. Earth is not separate from the cosmos. It's part of a solar system. The solar system is part of a galaxy, and the galaxy is constantly changing, evolving, moving through space. We are passengers on a cosmic journey that began billions of years ago and will continue long after we're gone. Participants in a story far larger than ourselves. The spiral arms are more than just beautiful patterns. They're engines of creation, regions where gas becomes stars, where stars become planets, where planets might, just might, become homes for life. And somewhere in the Orion Spur, on a small rocky planet, circling a modest yellow star. Life did emerge, simple at first, single cells, floating in ancient oceans. But over billions of years, complexity increased. It learned to swim, to walk, to fly, to build, to think, to wonder, to create art and music and mathematics, to look up at the night sky and ask, where do we come from? Are we alone? What is our place in this vast cosmos? The answer is written in the spiral arms, in the glowing nebulas, in the newborn stars, in the elements created in supernova explosions. We come from here, from the Milky Way, from stardust and gravity and time, from atoms forged in stars, scattered across light years, gathered by chance into a solar system, a planet, and eventually us. Let's continue our journey deeper into the galaxy, toward the bright center, where billions of stars orbit something mysterious and powerful. At the heart of the Milky Way lies a region unlike anywhere else in the galaxy, the galactic core, a dense, crowded, ancient place where stars are packed together thousands of times more tightly than in our neighborhood. Here, in our region of the galaxy, the nearest star to our Sun, Alpha Centauri, is about 4 light years away. If the Sun were a basketball, Alpha Centauri would be another basketball about 5,000 miles away. Vast empty spaces between stars. But in the galactic core, stars are much closer. The average distance between stars there is less than a light month. If our Sun were in the core, the nearest stars would be closer than the outer planets of our solar system. If you lived on a planet orbiting a star near the galactic center, your night sky would be breathtaking, overwhelming, alien, thousands of stars, visible to the naked eye, not scattered and distant, but close, brilliant, intense. The brightest ones would cast visible shadows at night, multiple shadows from multiple nearby stars. The sky would never be truly dark, even on a moonless night, even with your own Sun below the horizon. The combined glow of countless nearby stars would bathe everything in soft, perpetual twilight, a gentle silver light, illuminating the landscape. Even at midnight, you could read by starlight, navigate easily, see colors in the darkness. The concept of true night, of deep darkness, would be alien to you. But the galactic core is far away from us, about 26,000 light years from Earth, a safe distance. The light we see from the center tonight left there 26,000 years ago, long before human civilization, before writing, before cities, before agriculture, before humans even left Africa. When that light began its journey, humans were hunter-gatherers, living in small tribes, using stone tools, just beginning to develop language and art and culture. That light has been traveling through space all this time, crossing the galaxy at 186,000 miles per second, just to reach our eyes tonight. A message from the ancient past, from the heart of our galaxy. The core itself is hidden from view, at least in visible light. Thick clouds of dust, drifting in the galactic disk, block visible light from reaching us. When we look toward the center with optical telescopes, we see only darkness, obscuring dust lanes, silhouettes of molecular clouds. The core is completely hidden, veiled, mysterious, but other wavelengths pass through the dust. Infrared light, with its longer wavelength, can penetrate the dust. Radio waves, even longer, pass through easily. X-rays and gamma rays reveal the highest energy processes. And when astronomers observe the galactic core with these instruments, when they peer through the veil, they see something extraordinary, a supermassive black hole. At the very center of the Milky Way lies an object called Sagittarius A star, SGR A star for short, pronounced Sagittarius A star, named after the constellation Sagittarius, where the galactic center appears in our sky. It's a black hole, but not a small one, formed from a single collapsed star. Those are only a few times the mass of the Sun. This is something far larger, far more massive. Sagittarius A star contains the mass of about 4 million suns. 4 million, all compressed into a region smaller than the orbit of Mercury, smaller than the distance from the Sun to Mercury's closest approach. 4 million solar masses, compacted into an infinitesimally small point, a singularity where the laws of physics as we understand them break down, where space-time curves so steeply, so extremely, that not even light can escape once it crosses the event horizon. The event horizon, the point of no return, is about 12 million miles across. Tiny, compared to the immensity of the mass it contains. But once anything crosses that boundary, it's gone, forever, unable to escape, unable even to send a signal back to the outside universe. And yet, despite its enormous mass, despite its gravitational power, Sagittarius A star is relatively quiet right now. It's not actively consuming large amounts of material. No blazing accretion disk swirling into it. No jets of radiation screaming out at nearly the speed of light, as we see in active galactic nuclei in other galaxies. Just a silent gravitational anchor, holding the galactic core together, shepherding billions of stars in their orbits around it. Astronomers have been watching the stars near Sagittarius A star for decades, using the world's most powerful telescopes, tracking individual stars year after year, measuring their positions with incredible precision. Around the black hole, stars orbit at incredible speeds, some of them complete their orbits in just a few years. Just a few years to orbit something 4 million times the mass of the Sun, screaming around the black hole at thousands of miles per second, tens of thousands of miles per second, a significant fraction of the speed of light. Astronomers have watched these stars, tracked their motions, year after year, using the world's most powerful telescopes, the Keck telescopes in Hawaii, the Very Large Telescope in Chile, creating time-lapse movies showing stars orbiting the invisible black hole. By measuring their orbits, by tracking their speeds and paths, scientists can calculate the mass of the invisible object they're orbiting, and the numbers point unmistakably to a supermassive black hole. Nothing else could be so massive, so compact, so dark. One star in particular, called S2, or sometimes SO2, has an orbit that brings it incredibly close to Sagittarius A star. At its closest approach, S2 passes within just 17 light hours of the black hole's event horizon, just 17 hours at light speed, closer than the Sun is to the edge of the Oort cloud. At that distance, S2 is traveling at about 5,000 miles per second. That's roughly 3% the speed of light, fast enough to circle the Earth in about 5 seconds. And then, after whipping around the black hole, it swings back out on an elliptical orbit that takes 16 years to complete. Every 16 years, S2 makes another close approach, and astronomers watch eagerly, measuring, testing physics in extreme conditions. These stars, the ones orbiting close to the black hole, are like cosmic laboratories. Their extreme motions, their intense gravitational environment, test Einstein's theory of general relativity in conditions we can't replicate anywhere else in the universe. And so far, Einstein's predictions hold. The stars move exactly as general relativity predicts. Space-time bends exactly as the equations say it should. Gravity works, even in the most extreme environments, exactly as Einstein described over a century ago. In 2020, the Nobel Prize in Physics was awarded to 3 scientists for their work studying Sagittarius A star, for proving that a supermassive black hole exists at the center of our galaxy, for opening a new window into extreme gravity and black hole physics. But Sagittarius A star wasn't always quiet, not always dormant. Billions of years ago, when the galaxy was younger, the central black hole was likely feeding actively, consuming vast amounts of gas and dust, growing larger, radiating tremendous energy as material fell into it. During those epochs, the galactic core would have been a violent place, a blazing beacon, visible across half the universe, a quasar, outshining all 200 billion stars of the galaxy combined. But over time, the black hole exhausted its nearby fuel supply. The gas clouds in the core were consumed, or blown away by radiation pressure, or locked up in stars. The accretion disk faded, the jets shut down, activity declined. Now, Sagittarius A star rests, waiting, patient, occasionally feeding on a stray gas cloud or an unfortunate star that wanders too close, but mostly just existing, a dormant giant at the heart of the galaxy. Occasionally, a star wanders too close, passes within the tidal radius, where the black hole's gravity becomes so strong that it overwhelms the star's own gravity. The black hole's gravity shreds the star into streams of gas, pulling it apart in a process called tidal disruption. Like spaghetti being pulled apart, astronomers call it spaghettification, a real scientific term. The gas spirals inward, heating up as it falls, reaching temperatures of millions of degrees, emitting X-rays and gamma rays, creating a brief flare of activity that lasts weeks or months. Then, silence returns. The black hole goes back to sleep, waiting for the next meal. The galactic core is not just the black hole. It's an entire region, stretching thousands of light years, packed with ancient stars. Most of these stars are red giants, old, cool, stable, born billions of years ago. When the galaxy was young, many are 10 billion years old, 12 billion, nearly as old as the universe itself. They orbit the center in complex patterns. Some move in orderly circles, like planets around a sun. Others follow chaotic, elliptical paths, plunging close to the center before swinging back out into the disk. The gravitational interactions between stars and the black hole, between stars and gas clouds, create an intricate dance, a gravitational choreography playing out over millions of years. There's also gas, molecular clouds, dust lanes, nebulas, all swirling around the center, feeding occasional bursts of star formation. One such region, called the Central Molecular Zone, contains enough gas to form millions of new stars. Millions, more than enough to populate an entire small galaxy. But star formation here is sporadic, intermittent. The extreme gravitational tides, the powerful magnetic fields, the intense radiation from the black hole make it difficult for clouds to collapse and form stars. When stars do form here, they tend to be massive, high-mass stars, hot and bright, living fast and dying young. Lower-mass stars like our Sun rarely form in these extreme conditions. The galactic core is also home to something puzzling, something that scientists don't fully understand yet: an excess of gamma rays. Astronomers have detected a faint, persistent glow of gamma rays emanating from the center. More gamma rays than expected from known sources like pulsars and supernova remnants. What's causing it? No one knows for certain. Some think it's dark matter, invisible particles, perhaps WIMPs, weakly interacting massive particles, colliding and annihilating in the dense core, producing gamma rays as a byproduct of their annihilation. If true, this would be the first direct detection of dark matter particles, a revolutionary discovery. But the evidence is still uncertain, still debated. Others think it's thousands of undetected pulsars, rapidly spinning neutron stars, emitting beams of radiation like cosmic lighthouses, too faint to detect individually, but collectively producing the observed gamma-ray glow. Or it could be something else entirely, something we haven't thought of yet, some new physical process playing out in the extreme environment of the galactic center. The mystery remains unsolved. The investigation continues, despite its distance, despite being hidden behind veils of dust. The galactic core affects us. Its gravity holds the entire galaxy together. Every star in the Milky Way, all 200 billion of them, orbits the center, feels the pull of that concentrated mass. Even our sun, 26,000 light years away, feels the gravitational influence of the core. It's what keeps us in orbit, what prevents us from drifting off into intergalactic space. Without the galactic core, without that central mass, the galaxy would unravel. Stars would drift apart. The spiral arms would dissolve. The Milky Way would cease to exist as a coherent structure. But the core is there, massive, stable, eternal, an anchor in the darkness. And so the galaxy continues its ancient dance. Stars orbit, gas flows, new suns ignite, old stars die. The cycle continues, has continued for billions of years, will continue for billions more. Let's drift outward now, away from the crowded center, and explore the halo, where ancient star clusters orbit in silence, far above the galactic disk, beyond the glowing disk, beyond the spiral arms, beyond the flat plane where most of the galaxy's stars reside, stretches a vast, nearly empty region, the galactic halo. If the Milky Way's disk is a bustling city with millions of residents and constant activity, the halo is the quiet countryside, the remote wilderness, sparse, peaceful, ancient, unchanged. The halo surrounds the entire galaxy, a spherical region extending hundreds of thousands of light years into space, perhaps 200,000 light years from the center, wrapping the disk and core in a gentle, invisible embrace. The halo contains very little gas or dust. The interstellar medium here is nearly non-existent. No molecular clouds, no nebulas, no regions of active star formation, no bright young stars, just silence, darkness, emptiness, and scattered throughout this emptiness, like fireflies on a summer night, ancient relics of the galaxy's youth, globular clusters. Globular clusters are among the oldest objects in the universe, among the first structures to form after the Big Bang. Each one a tightly packed sphere of stars, hundreds of thousands of stars, sometimes 1,000,000 stars, bound together by gravity, orbiting a common center. They're small, compact, dense. A typical globular cluster might be only 100 light-years across. Compare that to the 100,000 light-years of the galactic disk. Tiny spheres compared to the vast flat disk. But within that small volume, stars are packed incredibly tightly. If you lived inside a globular cluster, if your planet orbited a star in one of these ancient spheres, your night sky would be absolutely ablaze with stars. Not hundreds of visible stars, like we see from Earth. Not even thousands, tens of thousands, hundreds of thousands. So many stars that they would blend together, creating a soft glow across the entire sky, bright enough to cast shadows, bright enough to read by at midnight. The brightest stars, the nearby ones, would appear as brilliant points, close enough that neighboring star systems would be just a few light years apart, close enough that interstellar travel, if such a civilization developed it, would be far more feasible than from our isolated position in the galactic disk. Close enough. The planetary systems might be disrupted by close encounters with passing stars, making stable long-term orbits difficult, perhaps making life itself less likely in these crowded environments. The Milky Way has about 150 known globular clusters, perhaps a few more that are hidden or too distant to detect easily. They orbit in the halo, scattered around the galaxy like a swarm of bees around a hive. Most of them orbit in highly elliptical paths, drifting along elongated orbits, plunging through the galactic disk, then soaring back out into the halo in orbits that take hundreds of millions of years to complete. As they pass through the disk, they remain intact. The stars within them are so tightly bound that the gravitational tides of the disk can't tear them apart. They're like cosmic bullets, passing through the galaxy unharmed. These clusters are ancient. The stars within them are some of the oldest in the galaxy. Among the oldest in the universe, 12 billion years old, 13 billion, nearly as old as the universe itself, which is about 13.8 billion years old. They were born when the Milky Way was still forming, when the galaxy was young and chaotic, before the disk settled, before the spiral arms emerged, when the universe was just 1 billion years old. Back then, the universe was different. No heavy elements yet, no carbon, no oxygen, no iron, just hydrogen and helium, created in the Big Bang. The stars in globular clusters reflect that ancient composition. They're metal poor in astronomical terms. Metals means anything heavier than helium. So metal poor means lacking in heavy elements. They contain very little carbon, very little oxygen, almost no iron, tiny traces, perhaps 1/100th of what our sun contains. Why? Because they formed when the universe was young, before many generations of stars had lived and died, before supernovae had enriched the galaxy with heavy elements. These stars are made almost entirely of hydrogen and helium, the primordial elements forged in the Big Bang, when the universe was just minutes old. Studying these ancient stars is like archaeological excavation, digging into the galaxy's past, understanding its formation, its evolution, its history. Globular clusters move through the galaxy like cosmic travelers, wanderers, unaffected by the spiral arms, unperturbed by the disk's rotation. Their orbits carry them through the galactic plane. Twice each orbit, they pass through the disk like a stone sinking through water, then emerge on the other side, continuing their elliptical journey. One of the most famous globular clusters, easily visible from Earth, is M13, the Great Cluster in Hercules, one of the brightest clusters in the northern sky. It contains about 300,000 stars, perhaps more, hidden in the cluster's core, where stars are so densely packed they blur together even in our most powerful telescopes. Packed into a sphere roughly 145 light-years across, about 34 times the distance from the Sun to Alpha Centauri, a small volume containing 300,000 stars. M13 is about 25,000 light-years away from Earth, roughly the same distance as the galactic center, but in a different direction. Out in the halo, on a dark summer night, from a location far from city lights, you can see M13 with the naked eye, just barely, a faint, fuzzy patch of light. In the constellation Hercules, ancient astronomers noticed it, catalogued it, wondered what it was, a nebula, a distant galaxy. They couldn't resolve it into individual stars. Through a telescope, even a small one, it resolves into thousands of individual stars, a glittering sphere, dense at the center, more sparse at the edges, ancient, beautiful, timeless. Through a large telescope, like those used by professional astronomers, you can see tens of thousands of individual stars, measure their properties, their colors, their brightnesses, their motions, and from those measurements, astronomers have determined that M13 is incredibly old, about 11.65 billion years old, born when the universe was just 2 billion years old, nearly as ancient as anything in our galaxy. Globular clusters tell us about the Milky Way's past. By studying their ages, their compositions, their orbits, astronomers can reconstruct the history of our galaxy. They reveal that the Milky Way formed from the merger of smaller galaxies, that the halo is made of debris from those ancient collisions. When two galaxies merge, When their gravity pulls them together over hundreds of millions of years, their globular clusters survive. They're so tightly bound that even a galactic collision can't disrupt them. And so they end up scattered through the halo of the merged galaxy. Fossils of ancient collisions, witnesses to the galaxy's violent past. The halo also contains something mysterious, something invisible, something that dominates its mass, yet remains undetectable except through its gravitational effects. Dark matter. When astronomers measure the speeds of stars orbiting the galaxy, they find something puzzling, something that doesn't make sense according to the visible matter alone. Stars in the outer regions, far from the galactic center, tens of thousands of light years out, are moving faster than they should be. According to the laws of gravity, according to Newton and Einstein, and the amount of visible matter we can see, stars and gas we can detect, those stars should be moving slower, or they should be flying off into space entirely, escaping the galaxy's gravity, like swinging a ball on a string. If you spin it too fast, the string breaks and the ball flies away. If the galaxy doesn't have enough mass, stars moving too fast should escape. But they're not escaping. They're held in orbit, moving faster than expected, yet staying bound to the galaxy. Something invisible is holding them. Something massive, something we can't see. That something is dark matter, an invisible substance that doesn't emit light, doesn't absorb light, doesn't reflect light, can't be seen with any telescope, at any wavelength. It doesn't interact with normal matter except through gravity. It passes through ordinary matter as if it weren't there, like a ghost. And yet, it's everywhere, throughout the galaxy, surrounding us, filling the halo, outweighing all the visible stars and gas by a factor of 10. For every kilogram of normal matter in the Milky Way, stars, planets, gas, dust, there are about 10 kilograms of dark matter. The galaxy is mostly invisible. We don't know what dark matter is, despite decades of searching, despite sophisticated experiments deep underground and in space. We haven't detected the particles themselves, exotic particles, WIMPs, weakly interacting massive particles, axions, primordial black holes, something entirely beyond our current physics. The mystery remains one of the biggest unsolved questions in modern science, but we know it's there. We can measure its gravitational effects, map its distribution, track how it shapes galaxies across the universe. The galactic halo is where dark matter dominates. The halo's mass is mostly dark matter, perhaps 90% dark matter, 95%. The globular clusters, the scattered stars, the ancient remnants of merged galaxies are just passengers, drifting through an invisible ocean of something we don't yet understand, like boats floating on an invisible sea. We see the boats, but the sea itself remains hidden. The halo is also home to something called stellar streams. These are long, thin ribbons of stars stretching across the sky, trailing across hundreds of thousands of light years like cosmic necklaces, draping around the galaxy, the remnants of smaller galaxies or globular clusters that were torn apart by the Milky Way's gravity. When a small galaxy passes too close to the Milky Way, tidal forces rip it apart. The same tidal forces that create ocean tides on Earth, but vastly more powerful. Stars are stripped away, one by one, from the outer edges of the smaller galaxy, pulled by the Milky Way's gravity, stretched into long streams. These streams persist for billions of years, slowly dispersing, spreading out, fading into the halo. But for a while, they remain visible, detectable, traceable. By studying stellar streams, by mapping their positions and velocities, astronomers can map the Milky Way's gravitational field, learn about its mass distribution, its dark matter halo, understand how galaxies grow through mergers and accretion. One such stream, discovered in 2003, is the Sagittarius stream, the remnant of the Sagittarius dwarf elliptical galaxy. This small galaxy, containing perhaps a few million stars, is currently being consumed by the Milky Way, torn apart over hundreds of millions of years, stretched into long tendrils of stars. Its stars have been scattered into long streams, wrapped around the galaxy like ribbons, multiple wraps, because the streams have orbited the Milky Way several times. Eventually, the Sagittarius dwarf will be completely absorbed, completely destroyed. Its stars will become part of the Milky Way's halo, indistinguishable from other halo stars. Its identity erased by time and gravity. The halo is not static. It's not unchanging. It's evolving, growing, accreting new material from smaller galaxies. The Milky Way is a cannibal, a galactic predator. It grows by consuming its neighbors. Over billions of years, dozens of small galaxies have been devoured, pulled in by gravity, torn apart, their stars redistributed into the halo, their gas falling inward to fuel new star formation in the disk. It's not violent, not explosive, just inevitable. Gravity working patiently over cosmic timescales, and the process continues today, right now, as we speak. The Milky Way is pulling apart the Sagittarius dwarf, the Canis Major dwarf, several other small galaxies, the Magellanic Clouds, our two nearest satellite galaxies, visible from the southern hemisphere as fuzzy patches in the sky, will eventually share the same fate. In a few billion years, they'll drift too close, The Milky Way's gravity will capture them, pull them apart, absorb their stars. But this is not violent, not destructive, not cruel. It's just gravity, inevitable, patient, gentle. Stars from smaller galaxies become part of our galaxy. Their atoms, their stories woven into the Milky Way's ongoing narrative. Nothing is truly lost, just transformed, recycled, renewed. The halo is vast, quiet, ancient, mysterious. It holds the memories of the galaxy's past, the remnants of its early formation, the ghosts of galaxies long since consumed. And it reaches out, far into space, connecting the Milky Way to the universe beyond, to other galaxies, to the cosmic web, to the vast structure of the universe itself. Let's return now, inward, toward the disk, and think about our place in this vast structure, our tiny home, in a galaxy of 200 billion stars. Our sun is just one star among 200 billion, ordinary, unremarkable, middle-aged, stable, average in almost every way. Not the largest star, not the smallest, not the hottest, not the coolest, not the brightest, not the dimmest, just average, a typical yellow dwarf star, one among billions of similar stars scattered through the galaxy. But it's ours, and that makes it special, that makes it unique, that makes it the most important star in the galaxy to us. The sun resides in the Orion Spur, a minor spiral arm, or perhaps just a bridge between major arms, about 2/3 of the way out from the galactic center. It orbits at a distance of roughly 26,000 light-years from the core, not in the crowded center, not at the sparse edge, somewhere in between, moving at 515,000 miles per hour relative to the galactic center, fast enough to circle the Earth in just over 3 minutes, fast enough to travel from Earth to the Moon in 28 seconds, completing one full orbit every 225 million years, one galactic year, the cosmic year. Our location is fortunate, lucky, some might say perfect. We're far enough from the galactic center to avoid the intense radiation, the crowded star fields, the disruptive gravitational effects, the higher frequency of supernovae. Life near the galactic center, if it exists, faces challenges, more radiation, more gravitational disruptions, stellar encounters that might destabilize planetary orbits, and we're far enough from the galaxy's edge to remain within the enriched regions where heavy elements, carbon, oxygen, iron, silicon, are abundant enough to build rocky planets and complex chemistry. Out at the galaxy's edge, heavy elements are scarce. The interstellar medium there is less enriched, more primordial, mostly hydrogen and helium. Rocky planets, might be rare there, and without heavy elements, complex chemistry is difficult. Life as we know it might struggle to emerge. This region, roughly 20,000 to 30,000 light-years from the galactic center, has been called the Galactic Habitable Zone, close enough to the center for sufficient heavy elements to form rocky worlds, for enriched chemistry, for complex molecules, far enough out for stability, safety, time for life to emerge and evolve without being disrupted by cosmic catastrophes. Not too hot, not too cold, just right, like Goldilocks. Earth is one such world, a small rocky planet, the third from the Sun, just the right distance from its star, to have liquid water on its surface, covered mostly in water, oceans covering 71% of its surface, land masses, continents and islands, scattered across the blue, wrapped in a thin atmosphere, nitrogen and oxygen, transparent to visible light, protective against harmful radiation, teeming with life, millions of species, plants and animals, microbes and fungi, complex ecosystems, interacting, evolving, changing. For billions of years, life on Earth evolved in isolation, unaware of the galaxy beyond, unaware of the cosmos. Single cells, then multicellular organisms, then complex animals, fish, amphibians, reptiles, mammals, birds, and eventually, about 300,000 years ago, something new emerged. Humans, a species with large brains, capable of abstract thought, of language, of culture, of art and science and philosophy, a species capable of looking up and wondering. Ancient humans saw the Milky Way, that pale band of light stretching across the night sky. They didn't know what it was. They couldn't. They lacked the tools, the knowledge, the perspective. But they wondered. They created stories, myths, explanations that fit their understanding of the world. Some cultures saw it as a river, a celestial river flowing through the heavens, the river that souls travel after death. Others saw it as a path, a road connecting Earth to the realm of the gods, the path the gods take when they descend to visit humanity. Some saw it as milk, spilled from the breast of a goddess. Hence, Milky Way, a name that persisted across cultures and centuries. Different stories, different interpretations, but all recognizing that this band of light was something special, something mysterious, something worth wondering about. It wasn't until 1610 that humanity began to understand. Galileo Galilei, an Italian astronomer, pointed a newly invented telescope at the Milky Way, and he saw stars, thousands of them, faint stars, too faint to see individually with the naked eye, but there, countless, uncountable, Not a glowing mist, not a river, not spilled milk, but stars, distant suns, each one perhaps with its own worlds. It was a revolution, a revelation, the beginning of understanding our place in the cosmos. But even Galileo didn't fully understand. He knew the Milky Way contained many stars, but he thought, perhaps, that this was the entire universe, all the stars, collected in this band of light. Centuries passed, telescopes improved, astronomers measured, mapped, debated. What is the Milky Way? How big is it? What is its shape? Is it the entire universe, or just one part of something larger? In the early 1900s, this was the greatest debate in astronomy. The Great Debate of 1920 between astronomers Harlow Shapley and Heber Curtis. Shapley argued, the Milky Way is the entire universe, a vast collection of stars, and those fuzzy patches we see, nebulae, are just gas clouds within our galaxy. Curtis argued, the Milky Way is just one galaxy among many, and those fuzzy patches are other galaxies, island universes, scattered through space. In the 1920s, Edwin Hubble, using the 100-inch telescope at Mount Wilson Observatory, settled the debate. He observed a fuzzy patch called the Andromeda Nebula, and within it, he found Cepheid variable stars, stars whose brightness varies in a predictable pattern. By measuring their brightness and period, he could calculate their distance, and he found Andromeda was far away, nearly 1 million light-years away, far beyond the Milky Way. It wasn't a nebula, it was a galaxy, another Milky Way, an entire island of stars, separate from our own. The universe suddenly became vastly larger, not just one galaxy, but billions, each containing billions of stars. And the Milky Way, our home, was just one among countless others, one island in an infinite cosmic ocean. But the Milky Way is still our home, still special, and it's unique. Every galaxy has its own history, its own structure, its own collection of stars and worlds, its own story. The Milky Way is not the largest galaxy. Andromeda is larger. IC 1101, a giant elliptical galaxy, contains 100 trillion stars, 50 times more than us. It's not the brightest, not the most active, not the most dramatic, but it's ours, our home, the galaxy that gave birth to us. When you look up at the night sky from a dark location, away from city lights, and see that faint band of light, you're seeing your home from the inside. You're looking through the disk, through layers of stars, through gas and dust, toward the spiral arms, toward the core. Each faint point of light is a star. Each star potentially hosting planets, rocky worlds, gas giants, moons, asteroids, comets, And on some of those planets, perhaps life has emerged. Perhaps other beings looking up at their own night sky, seeing their own Milky Way, wondering if they're alone. We don't know yet. We haven't found them yet, but the search continues. Radio telescopes, like SETI, listen for signals. Space missions, like Kepler and TESS, search for exoplanets. Scientists analyze distant starlight, looking for biosignatures in planetary atmospheres. And one day, perhaps, we'll find the answer. Perhaps we'll detect a signal or find chemical signatures of life in a distant atmosphere, or make contact. Or perhaps we are alone, the only intelligence in the galaxy, the only species capable of understanding the cosmos. Either answer is profound. Either answer changes everything. Our place in the galaxy is humbling. We are tiny, insignificant on cosmic scales. One planet orbiting one star in one small corner of a galaxy containing 200 billion stars. Our entire history, all of human civilization, has taken place in the blink of an eye on cosmic timescales. The pyramids were built just 4,500 years ago. The universe is 13.8 billion years old. We are newcomers, latecomers to the cosmic story. And yet, we are here, conscious, aware, able to comprehend the vastness around us, able to ask questions, seek answers, marvel at the beauty of the cosmos. Carl Sagan, the famous astronomer and science communicator, once called Earth a pale blue dot. In 1990, the Voyager 1 spacecraft, having completed its mission to the outer planets, turned its camera back toward Earth from a distance of 3.7 billion miles. In the image, Earth appears as a tiny pale blue pixel, less than 1 pixel, a speck, nearly invisible against the vastness of space. Sagan wrote about that image. Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. Everything we've ever known, every person who has ever lived, every civilization that has ever risen and fallen, every war, every peace, every triumph, every tragedy, every love story, all of it happened on that pale blue dot. And that dot orbits a modest yellow star in the Orion Spur, in the Milky Way galaxy. But our insignificance is not a source of despair, not a reason for nihilism. It's a source of wonder, of connection, of perspective, of humility. We are part of something vast, something beautiful, something ancient, something ongoing. The atoms in our bodies were forged in stars billions of years ago, in the nuclear furnaces of massive suns that exploded as supernovae long before our sun was born. The carbon in our cells, the calcium in our bones, the iron in our blood, the oxygen we breathe with every breath, all of it created in stars, released into space when those stars died, drifting through the galaxy, until gravity pulled it together into a new solar system, a new star, new planets, new life. We are, quite literally, made of stardust, made of the Milky Way, made of atoms that have existed for billions of years, that have been part of countless stars, countless worlds. And now, for a brief moment, they're part of us. The Milky Way made us, gave us the elements, provided the stable environment, shaped the solar system that became our home. And now, we look back at the galaxy and understand it, study it, marvel at it, ask questions about it. The galaxy has become aware of itself through us. In a way, we are the Milky Way's way of knowing itself, of experiencing its own existence, of asking, what am I? Where did I come from? What will I become? These questions have no final answers. The universe is too vast, too complex, too full of mysteries, yet unsolved. But the search for answers is what makes us human, what drives us forward, what gives our brief existence meaning. And as we search, we continue to learn, to discover, to expand our understanding. We've mapped the spiral arms, measured the black hole at the center, discovered thousands of exoplanets orbiting other stars, listened for signals from distant civilizations. We've launched space probes, Voyager 1 and 2, that have left the solar system entirely, entered interstellar space, carrying messages from Earth, golden records containing sounds and images of our world, music, greetings in many languages, pictures of Earth and its inhabitants, diagrams showing our location in the galaxy. Those probes will drift through the Milky Way for billions of years, silent ambassadors from humanity, carrying the story of Earth to the stars. One day, perhaps millions of years from now, perhaps billions, another civilization might find them, intercept them, decode the messages, learn about Earth, about humans, about our hopes and dreams. Or perhaps they'll drift forever, alone, never found, lost in the vastness. Either way, they're a testament, a message that says, we were here, we existed, we looked up at the stars, we wondered, we reached out, we tried. The Milky Way will continue long after humanity is gone. In 5 billion years, our sun will exhaust its hydrogen fuel. Its core will contract. Its outer layers will expand. It will become a red giant, growing so large it will engulf Mercury, Venus, possibly Earth. The Earth, our home, will be gone, vaporized, absorbed into the dying sun. Then the sun will shed its outer layers, creating a planetary nebula, leaving behind a white dwarf, a dense, hot, slowly cooling ember, the size of Earth but containing the mass of the sun. The solar system will be unrecognizable, dead, silent, but the Milky Way will still be here, spinning, patient, eternal, continuing its cosmic dance. And in 4.5 billion years, just about the time our sun is dying, the Milky Way will collide with Andromeda, two spiral galaxies, approaching each other at 250,000 miles per hour, drawn together by gravity over billions of years. They'll merge over hundreds of millions of years, not violently, not explosively. Stars will pass between each other like ghosts. The distances between stars are so vast, actual collisions between stars will be incredibly rare. But gas clouds will crash together, compressed, heated, triggering enormous bursts of star formation. Billions of new stars, born from the collision. The combined gravity will distort both galaxies, pulling them into new shapes, creating tidal streams of stars, disrupting the spiral structures. Eventually, they'll form a single giant elliptical galaxy, quiet, majestic, ancient, containing the stars from both the Milky Way and Andromeda, 1 trillion stars or more. Astronomers have already given it a name, Milkomeda, or sometimes Milkdromeda, the merger of Milky Way and Andromeda. By then, humanity will be long gone, billions of years in the past. Perhaps only fossils remain, perhaps nothing at all. But the atoms that once made up our bodies will still exist, scattered, recycled through the galaxy, perhaps part of new stars, new planets, new life. Carbon atoms from your body might end up in a distant star, oxygen atoms in a molecular cloud, iron atoms in a rocky planet orbiting an alien sun. We are temporary, but the atoms we're made of are eternal, recycled endlessly through the cosmos, from stars to planets to life and back again. We are temporary, but the universe is eternal, or at least so vast in time that it might as well be. And that's okay. That's beautiful even, because right now, in this moment, we are here. We are alive, conscious, aware of the Milky Way, part of its story, witnesses to its beauty. So when you look up tonight and see that pale band of light, that river of stars, remember, you are home. You belong here. You are made of stars. You are part of this galaxy, part of this vast cosmic story. The same atoms that make up your body once floated between the stars, were forged in supernova explosions, drifted through the cold dark for billions of years, until they came together on this small planet to become you. And one day, those atoms will return to the stars to begin the cycle again, and the galaxy spins gently onward forever. And so, we drift through these peaceful truths about the Milky Way, a galaxy of 200 billion stars stretching 100,000 light years across, spinning slowly, patiently through the void. And in one small corner, on a rocky planet circling an ordinary star, life emerged. Life that learned to look up, to wonder, to ask questions. Every atom in your body was forged in the heart of a star. The carbon in your cells, the calcium in your bones, the iron in your blood, the oxygen you breathe with every breath, all of it created billions of years ago in stellar furnaces, released into space when those stars died, scattered across light years, drifting through the galaxy until gravity pulled it together, formed a new star, a new solar system, a new world. You are, quite literally, made of the Milky Way, stardust, shaped by gravity, animated by chemistry, given consciousness through billions of years of evolution. And now, you look back at the galaxy that made you. You see it, understand it, marvel at it. In a very real sense, the Milky Way has become aware of itself through you, through us. This connection runs deep, deeper than words can express. We are not separate from the cosmos. We are part of it, woven into its fabric, participants in its ancient ongoing story. The same gravity that holds galaxies together holds you, keeps your feet on the ground, keeps Earth in orbit around the sun, keeps the sun in orbit around the galactic center. The same nuclear forces that power stars, power the chemistry of life. The fusion of hydrogen into helium in the sun creates the light and heat that makes life possible on Earth. The same laws of physics apply everywhere. To distant quasars at the edge of the universe, to spinning pulsars, to black holes, to your own body. Everywhere, the same laws, the same forces, the same fundamental constants, connecting everything across space and time. There's comfort in this knowledge, deep comfort. We are small, and yet we are everything. We are made of the universe. We are the universe experiencing itself, temporary and yet eternal. Our bodies are temporary, but the atoms we're made of will exist forever, recycled, renewed, part of new worlds, new stars, perhaps new life, alone, and yet connected to all that is. We may be the only intelligence in the galaxy, or we may be one among millions. But either way, we are connected to every star, every planet, every atom in the cosmos. The Milky Way is vast, ancient, patient. It existed long before us, 13.6 billion years ago, when the universe was just 200 million years old. The first proto-galaxies began to form. Over billions of years, they merged, grew, became the Milky Way we see today. It will exist long after, in trillions of years, long after the last stars have burned out. The galaxy will still exist, dark, cold, but still there, still spinning through an increasingly empty universe. But right now, in this moment, in this brief window of cosmic time, we are here, part of its story, witnesses to its beauty, participants in its ongoing evolution. And perhaps that's the most profound truth of all, that we, fragile, temporary beings, can comprehend infinity, can look up at 200 billion stars and understand them, map them, name them, study them, learn their secrets. That we, made of atoms forged in stars, can understand how those atoms were created, can trace our lineage back to the Big Bang, can see our own origin story, written in starlight. We are the universe, looking back at itself, asking questions, seeking answers, finding wonder in every discovery. So rest easy tonight, knowing you belong here. You are made of stars. You are part of the galaxy. You are connected to everything that has ever existed, every star that has ever shined, every planet that has ever formed, every atom created in the Big Bang. The Milky Way spins gently onward, as it has for billions of years, as it will for billions more. And you drift peacefully within its embrace, safe, home, part of something vast and beautiful and eternal. Our journey tonight comes to its gentle close. We've drifted through the spiral arms, where stars are born in glowing nebulas, explored the ancient core, where a supermassive black hole anchors the galaxy, floated through the quiet halo, where ancient globular clusters orbit in silence, and found our place among 200 billion stars in this vast cosmic home we call the Milky Way. If you've enjoyed this peaceful exploration of our galaxy, if you found rest here under the stars, perhaps consider liking this video, subscribing to Calming Cosmos, for more nightly journeys through space. But there's no pressure, no obligation, just rest, just peace. Share this with someone who loves the cosmos, or someone who struggles to sleep, or simply someone who needs a moment of peace in their day. Thank you for traveling with us tonight. Thank you for seeking wonder under the stars, for taking this time for yourself, for allowing yourself to drift, to rest, to find peace in the vastness. Sleep well, traveler. Dream of spiral arms, glowing softly in the darkness, of ancient clusters, orbiting for billions of years, of stars being born in distant nebulas, of worlds yet undiscovered, of possibilities yet unimagined. Remember, you are stardust, you are ancient, as old as the atoms in your body. You are temporary, your form will change. You are eternal, the atoms will persist forever. You are small, a brief flicker in cosmic time. You are infinite, connected to all that is. You are part of the Milky Way, and the Milky Way is part of you. Rest now, let go, float peacefully through the galaxy. Good night, and sleep well.